Hello everyone, I am Dr. Assem. I'm your instructor for this module, Applied AI and Deep Learning. And I will start with give you some background, the relationship between AI and deep learning, and of course, machine learning and artificial neural network. So, like you know, guys, the CS is a part of CS computer science, is a part of practical science. And inside this CS, you will find subcategory inside here called AI. AI, artificial intelligence, is a branch of computer science, like just like other branches, programming, algorithms, data structure, cloud computing, networking. So artificial intelligence, AI, is a branch of computer science. Inside this branch, you will find a set of algorithms here is called machine learning. Machine learning. So machine learning is a subset of AI, and AI is a subset of computer science. Inside machine learning, you will find artificial neural network, this ENN, this one. So ENN is a subset of machine learning, which is a subset of AI, which is a subset of CS. A part of a artificial neural network, you will find deep learning. So in fact, deep learning is a subset of artificial neural network, and the artificial neural network is a part of machine learning, and the machine learning is a part of AI, and AI is a part of computer science. The question now, what's the difference between the algorithms inside CS and the algorithms inside AI? Okay, before I go to this question, I will ask you another question. What does the algorithm means? What's the definition of algorithm? Algorithm, algorithm means a sequence of steps to achieve a goal or to solve a problem, to do some tasks. So sequence of steps, this means algorithm. If you ask me about my algorithm to go to Grange Gorman building, to Dublin Grange Gorman campus, it's easy for me. I will tell you, I will get off my home and I will take a left for walking for 10 minutes, and I will find bus stop, and I will take 155 to Grange Gorman station, and I will walk, I'll take a ride for 4 minutes and left. I will find my office for I will find the Grange Gorman building. Okay, so if you follow my steps, you will get the same result. So actually, the algorithm is a sequence of steps. Anyone follow these steps, you will get the same result. If I ask you, what's your algorithm to make a cup of coffee? So you will tell me your steps to make a cup of coffee, and I will follow your steps, and I will get the same result. I will get a cup of coffee. This is exactly what the algorithm means. And algorithm actually is the most famous term in all sciences, algorithm. Algorithm, again, is a sequence of steps. So any computer, let me do something here. Any algorithm here in computer science, it will be this algorithm in computer science here, it will be the same definition, right? A sequence of steps to perform a task or to achieve a goal. And we are, as a programmer, we can put these steps in programming language, Python, Java, C++, C Sharp, and these programming language can do the same task. Also, we have some algorithms here in AI, but it's a bit different because the algorithms in AI, it is intelligent algorithms. The algorithms can perform tasks that need human intelligence. So if we need some human intelligence, this AI algorithm, okay, and we call it intelligent algorithms. Okay, so we know now the difference between any algorithm in CS and particular algorithms in AI. What about the algorithms in machine learning? What's different? What's the special about these algorithms? These algorithms, guys, it is able to learn. It is machine learning. It's able to learn. To learn from what? To learn from data. So machine learning also is a set of algorithms. These algorithms can learn from data. Why do we need learning from data? Because for specific problems, guys, we cannot write a program computer to do this. A computer program, sorry, a computer program to do this. If I ask you to write a program to recognize a face, how can you do it? It is not easy to do it, all right? Because actually we don't know how our brain does it, okay? So how our brain do this? So it is not easy. It is easy to collect many examples and you train your model, and then your model will be able to recognize such this data he trained on. Okay, so machine learning algorithms it is intelligent algorithms and they need human intelligence, and they solve a problem that needs human intelligence, but in same times it able to learn. Okay, what about the algorithms inside artificial neural network? Artificial neural network, actually, it is a mimic to our brain. So we try to learn the same way human being learn. So the special about algorithms in artificial neural network, it is these algorithms try to learn, but in the same way the human learn. All right. And here a deep learning is artificial neural network, but with the multiple layer, with a multiple layer. Because guys, a neural network in our brain, it is huge actually. How do you know how many neuron we have in our brain? It's about 1 billion neuron. It means 100, I say 1 billion, it is 100 billion neuron. It is 100,000 million neuron. So it is so much neuron. These neurons, it's arranged into layers, and these neurons connect to each other. It's about trillion connection between them, or 100 trillion connection between them. So actually, if we have a problem, not just need 3 level or 3 layers, okay, we can call it artificial neural network. If we have a problem, we need 10 layer, we can call it deep learning, deep artificial neural network. So the difference between deep learning and artificial neural network, it's deep learning, it is artificial neural network with multiple layers. Actually, we don't have a threshold between the deep learning and the shallow learning, but any two types of artificial neural network, if you have one of them 3 layers and you have the other one is 6 layer, you can say the one with the 6 layer, it is deep learning and deeper than the one with the 3 layers. Okay, again, guys, computer science is a set of algorithms. These algorithms perform a tasks, right? But artificial intelligence here, guys, is a set of algorithms that needs human intelligence, right? And the machine learning is a set of algorithms, each one of them able to learn from data. And artificial neural network, this learning or this learning, it is the same way human being learn. So artificial neural network, it's a mimic for our brain. And deep learning is multiple layer of artificial neural network. So let me do something here. I will come here. I would say, let's say the deep learning, okay. What's this? Deep learning, it's equal deep artificial neural network. Okay, and we can call it deep neural network. So if I say neural network, I mean just neural network. I don't mean biological neural network. I mean artificial neural network. So from here, guys, we learn two things. We learn what the difference between the algorithms in each part, and we learn that deep learning is a part of artificial neural network, and the artificial neural network is a part of machine learning, and machine learning is a part of AI, artificial intelligence, and AI is a branch of computer science. Okay, actually, I'd like to add one thing here. Do you know what is the computer before AI and the computer after AI? The computer before AI, guys, is just a traditional computer. We need to just put the input and we build the program and to give me the output. But after AI, actually, this computer can learn its intelligence. So we put the input and we build the output, and this computer can form the program that relate between the input and the output. So we put input and output, and he gave me the program, right? Not input and program to give me the output. No, we put input and output to give me the program. And this program, I can use it later with the new input to give me a new output. So that's what about the era of artificial intelligence. That's what makes our computer to change from algorithmic machine to intelligent machine. In case of you don't know, guys, we have 3 types of machine. We have one thing is called the machine, the other thing is called algorithmic machine, and the third thing is called intelligent machine. Anything is called a machine. Like the barrel of water is machine. The chair I sit on it is machine. The spoon is machine. The blender is machine. The fork is machine. The pen is machine. My notebook is machine. Anything is called a machine. But we have another thing. It's called intelligent machine, and the intelligent machine is the human being. There's the intelligent machine. Between these two, there is something else is called algorithmic machine. Algorithmic machine, that means this machine follow the steps to reach to the correct result. Like what? Like your calculator. If you write on the calculator 3 plus 5, it give you 8. Okay, but in fact, calculator doesn't know what is the 3 and doesn't know what is the 5 and doesn't know what's plus. But it's follow the steps and to give you the correct answer. So calculator is algorithmic machine. Also, as example of algorithmic machine, the washing machine. The washing machine give it first washing and then spin. Yeah, so it's a sequence of steps to give you a correct result. So, and also the computer. Computer is algorithmic machine. Follow the steps to give you the correct result. But in artificial intelligence, we try to convert computer from algorithmic machine to intelligent machine. So now we have just a machine, algorithmic machine, and intelligent machine. And we have intelligent machine, which is the human being, and anything else that's called the machine. And the algorithmic machine is a set of machines that can follow these steps. One of them is a computer. We try in AI to convert the computer from being algorithmic machine to be intelligent machine. Okay, so this the artificial intelligence, and I'm sure you are aware about some artificial intelligence concept and also machine learning. You study machine learning before, but in this course and this module, we will be learn about artificial neural network and deep learning. Before to go into artificial neural network, let's see what's the actual neuron looks like in our brain. That, guys, what the neuron looks like in our brain. Okay, that's the neuron. It's called cell nucleus, and these dendrites, or sometimes we call it synapses, this one, and this it's the input for this neuron. And after the neuron take this input, do his thinking, and give the output, give his decision through this axon. Okay, and after this action, this decision, this input, this output go to the another neurons. Let's say this neuron is the part of our layers here. We have the neuron, many neurons arranged in layers. Okay, so this input come from previous layer, and this output going to the next layer. So any neuron actually take his input from previous layer and do his part of thinking and give his decision to the next layer. Okay. Also, maybe this neuron in the front layer, if it is in front layer, so he takes his input from the data from the outside and do his thinking, and then he can give the output to the synapses here. Okay. How can I can mimic this mathematically? Yeah, this good thing. To mimic this mathematically, guys, we do something called perceptron. Okay, so perceptron is a mathematical representation for neuron. Perceptron is a mathematical representation for this neuron. If I were you, I will come here. Maybe the same cell right here, and take the input from previous layer or from outside, and then do the part of thinking, and they give the output. That's all. Okay, if you have here, let's say this apart. Okay, let's say the x1. Sorry for bad handwriting. X1. Okay, okay, is this? And this x2. And this x3. Okay, and then this input go on here. I mean, this x1. This one. and this input go to the neuron here, like this intrinsic right here, and he do his part of thinking and give the output here. Let's name the output in this case Y. Okay, so this is the biological neuron, and this is the artificial neuron. And this representation called perceptron. Perceptron is the mathematical representation for neuron or even for neural network. By the way, I can name this representation 3, 1. What that means? That means I have 3 input and I have 1 output. Of course, I can have 5, 6, 7, 2, any number of input, and I can have any number of output. Okay, so in this case, 3, 1. 3 input and 1 output. Okay, but if you ask me how many layer of neuron here, I will tell you 1, because the 3 is just input. This not neurons. This just neuron. This input from outside, and this is the only neuron we have. Okay. So how actually this neuron thinking? This is good thing, all right? Actually, he do 2 tasks. He take this take this input and he cook it together and then make decision. So first take the input, cook it together, and make decision. Okay, I will give you an example. If you would like to buy a house, okay, so let's say this neuron want to buy a house, all right? So if I'd like to buy a house, I will ask my friends about this house, and I will take their opinion, and I will think this opinion good, okay, and I will make decision. Okay, this opinion, I collect them together. So if one of them give me his opinion X1, and the other one give me X2, and the third one give me X3, I will do X1 plus X2 plus X3. Let me do this. Okay. Okay, so I would say I will do X1 plus X2 plus, sorry, X2 plus X3. Okay, so I collect them together. But actually, X1 and X2, X3, my friends, I don't trust them all as the same, because some of them is more experience about housing, the other one less experience, the third one maybe doesn't have that much experience. So each one of them has a different weight, in my opinion, in my head, all right? So I will call this weight 1 and this weight 2 and this weight 3. So each one of them has different weight. I don't trust them all the same. So when I'm collecting these data, actually I'm doing this. I say W1 X1 and W2 X2 and W3 X3. Sorry for bad handwriting. So I will collect them all. Let me call it Z. So this the data I collected from previous layer or from outside. Okay, and then I will make my decision to buy a house or not to buy a house. So I will give I will map this collection, this summation to one decision. Even I will buy a house, 0. I will not buy a house, or I will buy a house. Okay, let's say if this Z greater than specific threshold A, okay, I will, sorry, if this is less than a specific threshold, I will not buy a house. But if it is greater than specific threshold, I will buy this house. Threshold, guys, means limit. So I need this opinion to convince me to be greater than a specific limit to buy this house. If it is not greater than a specific this specific limit, this threshold, I will not buy a house. Okay, so this a function. Actually, it's a function in Z. So if the Z greater than some level, I will buy the house. If it is not greater than this, I will not buy this house. So let's say this will be the output Y. So actually, what happened here is 2 tasks, 2 computation, two type of calculation. The first one, I calculate Z, which is the summation of x1 W1 plus x2 W2 plus x3 W3, and then I will map this summation to decision to take a y. Okay, and I will do the get a y. So I need two things here. I calculate, make the summation, and then I put it in activation function. Activation function because this calls the activity. There's a decision. All right. So how actually the neuron think about any decision? We say we do this input times weight and then activate. Input x1, x2, x3 times weight w1, w2, w3. And then after this summation, I will activate it. I put it in the activation function. In this case, guys, in the example I give it to you, the activation function was, activation function is 0 or 1. 0 when I will not buy a house, or 1 when I buy a house. This function, guys, is called the threshold function because the threshold function is it is hard limit function. If you try to draw it, it will be like this. This function will be like this. This x and y, and at the specific a, the data equal 1, and the same a data equal 0. So this hard limit function or threshold function. Okay. So again, guys, what is how the neuron thinking? Two steps. It's the first step. It is take the input and times the weight because not each input has the same weight. And then after this calculation, we need to make a decision. We put it in activation function. Again, my song is input times weight and then activate. Input times weight and then activate. Okay. Guys, now I will go to this is my first my introduction, and now I will show you the slides and start from there. Oh yeah, correct. I don't think it's okay here. I delete this. So these are our slides, guys. The first slides here. Applied AI and deep learning, and we learn together. The deep learning is a part of artificial neural network, and the artificial neural network is a part of machine learning, and the machine learning is a part of AI. This course concerns about artificial neural network and deep learning. Okay, you already enroll in this course, and these two books, right? It's okay. These very nice books, and I think it is very easy for you to read. And actually, I will try to explain every part in these slides. And if I find anything missing, I will add some materials for you. Okay. So all the course is concerned about perceptron and how this calculation happened, and it's called the forward pass or forward propagation, and how learning happened, and some code about keras and artificial neural network, and some issue about hyper parameter and deep learning connecting, and how to deal with the images and how to deal with the text and so on. So this course actually it gives you a good start in artificial neural network and deep learning. So in artificial neural network, in this slide, you'll find here instead of saying artificial neural network, you can just call it just a neural network. So if we say neural network, wouldn't in computer science wouldn't mean the biological neural network. Maybe in neuroscience, if they say neural network, they mean the biological one. But if we say neural network, so we mean artificial neural network. And the goal of artificial neural network to create realistic model for our brain, to make the structure of our brain and same time to learn the way our brain learn. Okay. Uh, Same thing, just artificial neural network, just like any machine learning, has ability to learn from data, and then it can used for any new data. Okay. The same, you will find the same thing here. What is the history of artificial neural network? Actually, the first step in artificial neural network was in 1943 when we recombine the neuron with the Turing machine. I think you studied Turing machine, so this was the first step. They put neuron, how to make a neuron, mathematical neuron, with the Turing machine. And then the receptron, the one we saw now, it is created in 1958. And then in 1969, the Minsky and Papert find a limitation of this representation, and from this time the research stopped until 1983, until the back propagation algorithm that teach us how perceptron can learn. And also, in this time, the research stopped until 2006. And I remember in this era, guys, the duration, I was trying to take my first step in scientific research. And they told me, don't try to think about neural network because neural network will not get any better. So we actually in this time, I didn't think about neural network. But in 2006, this guy, Hinton, he solved the problem of deep learning. And from this time, 2006 until now, all I think all the artificial intelligence product is depend on his invention in deep learning. Okay. Like you see here, guys, like you see here, it is the same biological neural network. These input parts, call it synapses or we call it dendrites, and the thing can happen here, and the output go through this axon. Here you can see here this picture for multiple neuron. It is neural network. So it is not just one neuron. It is multiple neuron. That's what we and connected together. So that's what we call it neural network. And you will find here this a picture of your brain that has 100 billion neuron and 100 trillion connection between these neurons. This your brain, uh, guys. Perceptron, the computational representation or mathematical representation of neuron, and contains of input and weight and activation and output. Okay, activation function could be different. We talk about one activation function, this one, the threshold, but this threshold is good if you're gonna take a decision, yes or no. I will buy a house, I will not buy a house, I will go somewhere, I will not go this way. So it is 0 or 1. But what about if you build a neural network to predict a house price? This not 0 and 1, this multiple value. So the threshold in this case would not be enough, and you need to think about another types like linear or sigmoid or Gaussian. We will go through this activation function, guys, one by one. And what is the weight of perceptron? How it is important? I told you guys this input. Okay, we don't sum up all this input by itself because not all the input have the same weight. Not all the input has the same importance. So we need to multiply each weight by the input and make summation. After this, we will put it in activation function to take the decision. These guys is multiple layer neural network. It's not one like this. This was one neuron. But guys, look at this. Each circle of these is a neuron. Each one of these. And this output. So in this case, guys, this output, if we have output sorry, this input. If I say this in input layer, it's in the input, and we have one hidden layer here and one hidden layer here, and this output layer. So this input layer and this output layer and anything else, I would call it input layer. So neural network will be like a black box. We have input layer and output layer, and anything inside here is hidden layer. Okay. In this case, I will name this neural network N641. N641. But how many layer of neural network here? Three layers. This first layer and this second layer and this third layer. Because input layer is not neurons. It is not thinking part. So this not layer. Even I say N4641. But if you ask me how many layers we have three layers. This two hidden layer and this output layer. In this one, guys, let me name this with you. This will we will name it 4 and 4, 3, 4. Okay. But what is for input layer? We have 4 input. What is for output? And this the hidden layer. We have one hidden layer here. This is a hidden layer. 3 neurons. Okay. 3 neurons. Each one of which circle of this is one of the neurons. Okay. So here, if you ask me how many layers we have 2 layers. This layer, the hidden layer, and the output layer, because input layer is not one of the neural network layer. It's just the input. It is not part of thinking. This input comes from outside. Okay. So, all right, let me clean this. Okay, before I go any further, let me show you one thing here. Neural network. Let me show you any one of these. Let me look here. How to represent this neural network? It's 2, 3, 4, 1. 2, 3, 4, 1. Okay, this input layer 2 and output layer 1 and 2 hidden layer, like you see here. But if you ask me how many layers we have 3 layers. This layer, and this is the second layer, and the third layer. But this one is input layer. It doesn't count as one of the layer in your network. This also 3, 4, 4, 1. 3, 4, 4, 1. 3 input layer, 4 hidden layer 1, and 4 hidden layer 2, and output layer is 1 neuron. But the thinking, some thinking happen here, some submission and some activation function, and here, and also happen here, some input times weight and activation function here, and also here it is input times weight and activation function here. But here is just the input. It's just the input. So 3, 4, 4, 1. But how many layers we have? 1, 2, 3. Okay. Okay. Let me go back. All right, when we talk about backpropagation, we talk about learning. I will talk about this in details, but for now, let me tell you about the forward propagation. What the forward? Sorry guys, this structure for another neural network. Can you tell me what this? This is this 2, 2, 1. So this input 2 and the hidden layer, one hidden layer with the 2 neuron and the output layer 1. But how many layers we have here? 2. The 3, 4, 4, 2. How many layers we have here is 3. And this one to call it recurrent neural network. Recurrent neural network, that means the output of the neuron come back as an input of the same neuron or for the same layer. So that's what you call it, a recurrent neural network. And this could be good with the text. Any sequential data, we need to apply recurrent neural network or RNN. RNN, recurrent neural network. It is good to have to apply it when you have a text, have sequential text, because you need to connect between the words and each other. Okay. Also, this called long short-term memory, LSTM. When you are ready to try to teach your model text like ChatGPT, okay, we need to keep our memory. We talk about girl, right, or boy, or plural, or single. So we have a long memory. And at the same time, when we jump to another topic, we need to make this memory short. Okay, so it's called the long short-term memory, or LSTM. This deep convolutional network or convolutional neural network, actually, guys, is good for images, for parallel data, because the images we need to process all the pixels in same times. So this is called the convolution neural network. These deep learning should look at how many connection here, and this more deeper and more connection, and how we represent the images. All right. Actually, this just introduction about all these things, and we have some question. We need to answer this question in next lectures. What is a neural network should I use? Which one? How many layer I should use? And when I stop training, I will keep training until what limit? Okay. And how many hidden layer we need, and how many neuron in each layer, and what's the training rate? And what is the epoch size? How the epoch size means how much data I train. So all these guys, this question, this is just introduction, and I will teach you this 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 in details in next lectures. Okay. Let me now go to the question. I would like to give you a question and ask you for the answer. What about if I have this neuron, just one neuron, and we have the input, and this input, let's say this 0.5. Sorry for bad handwriting. Okay, and 0.3 and 0.1. And negative 0.2. What? Okay. So let me change the color. 0.2. And here I would like to calculate the output. Why? How to calculate the output? Like I said, guys, we have first we find Z, and then we find Y. How to find Z? Okay, let's do it together. Y equal, sorry, Z equal, yeah, 0.5, okay, times 0.1 plus 0.3 times 0.2. Okay, the answer is, mm, the answer is, I think, 0.11. Okay. Hope I didn't make any mistakes. Yeah, I think that's correct. 0.11. All right. And then this Z, I will put it in activation function. Let's say our activation function is the threshold function. It will be at this threshold function, I will make it 0 when I will make it 0 when Z greater than 0, less than 0, sorry, less than 0, and 1 when Z greater than 0. So in this case, I would say here Y equal 1, because according to this function, according to this threshold function, this one, Z greater than 0, this much is positive. I think I made mistake. Yeah, I made mistake. This negative here. Yeah, sorry guys, there is negative here. Yeah, it was negative 2. So this will be 0 point negative 0.01. I hope it's positive now, correct now. And according to this function, guys, y it will be negative 1. Okay, it will be negative 1. Yes, correct. All right, let me give you an example. What this example means. This example actually, it is, let's say I have a data, and this data represent the difference between, let's say, orange and apple, okay? And give me two features for each one. The feature is let's say the volume, the size, and at the same time the texture, okay? or the color and the texture, color and texture, right? So X1, it represents the color of fruit, and X2 represents the texture of this fruit. Okay. All right. And we have a data. We have the first object is 0.5 and 0.3. Okay. And the second one is 0.7 and 0.1. Okay, and I'll try to find out which one of these objects is apple and which one is orange. And let's say the apple is 1 and orange is 0. Apple is 1 and orange is 0. Okay, so I took this data first, this color and this texture for the same fruit, okay, 0.5 and 0.3, and I put it for the neural network here, 0.5 times 0.1 and 0.3 times negative 0.2, and give me this calculation negative 0.01. I hope it's correct now. All right. And when I use the activation function, this activation function 1 and 0, all right, tell me since it is negative, I will take it 0. So this will take it 0. So here 0. And in case of 0, it will be 0 here. And that means this fruit is orange. Orange. Okay, let's now use another example. Another example, yeah, I will ask you to do this yourself, but I give you a small help here. I will. I use this time 0.7 and this one 0.1. And let's make this neuron think about this type. If it is apple or orange, you would say 0.7 times 0.1 and plus 0.1 times negative 0.2. I think it will be 0.05 positive 0.05 positive. So I will put it in this activation function. It give me 1. So if it give me 1, that means this time it is apple. So we have now a neural network or one neural network. We can use it to differentiate between the apple and orange. Okay. All right. Let's make more example, better example. And this example supposed to be uh, with different numbers. Let me check this. Okay. All right. I will use this book to give you another example. So in this case, it. All right, this could be a bigger neural network, right? So this synaptic weight here. If you ask me how big this neural network, I would say 2, 1. This is the structure of this neural network. We have 2 input, and we have one output, and we have one hidden layer network, one hidden layer, and the hidden layer contains 2 neurons. But if you ask me how many layers we have, we just have these 2 layers, all right? We have the hidden layer and output layer. This is just input, okay? It doesn't count, all right? If we have some numbers here, let's say the number here is 0.15. No, 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 it's not correct. Not to do this. Color white. Okay. All right. 1 second. Okay, this again. 0.15. Okay, and this 0.7. Okay, and here we have a weight here 0.1, and the other weight here it is 0.3, and the other weight here negative 1.1, 0.2. Okay, and the weight here 0.4. Let me take it like this. Okay, and we have weight here 1.4, and the weight here negative 0.9. Yeah, just numbers. Guys, what we need here, guys, is to calculate for this input. What is the output here? It is orange or apple. So it will be different. Why it will be different? Because we have calculation here in this neuron, and the output of this, it will be input for the second layer. Let me do this with you. Okay, so I will divide this and divide this, because the two operations happen here. The two operations will happen here to calculate this Z1, Z1 and Z1, and this Y1, and this Z2, and this Y2, and this Z3, and this Y3, and they just calculate Y or Y hat. Yeah, that means they calculated Y. I mean here they calculated Y. I can name it Y3 by the way, but here I will name it Y or calculated Y. Let me make sure. Okay, so how to calculate the Z first? How? Oh, so come here. Let's say Z1 equal 0.15 times 0.3 plus 0.7 times 0.4. Like I say, guys, the Z1, the input here 0.15 times this weight, the weight here 0.3, and this one, the other input, because this collected two input right here, 0.7 times 0.4. Okay, and the output, I will put it in activation function. I'm sure it will be positive. So Y1, it will be 1. Why? Same activation function I talked about, guys. 0 if it is less than 0, and 1 if it is greater than 0. Got it? So if Z greater than 0, I will put Y equal 1. And if Z less than 0, I will put Y equal 0. This the same threshold function that determine if it is orange or apple. Okay? So Z2 equal this Z2, guys, 0.15 times 0.1 plus 0.7 times this times between brackets minus 1.2. Please calculate it yourself, guys, but I think it will be negative. Yes, it will be negative. So please make sure I did it correctly. So in this case, Y2, it will be 0 according to activation function 0 and 1. Okay. Okay, this Y1 and Y2, guys, it will be the input for the second layer, for the layer here. So in this case, if you would like to calculate y3, z3 equal y1 times this weight, y1 here equal 1 times the weight 1.4 plus y2, it is 0 times negative 0.9. Okay, and this gives me 1.4. Oh, I made some mistake again. This not 8 this times. Okay, 1.4 the here 1.4 the summation, and for this y3 or y hat the output equal 1. So this apple, because I told you it was apple equal 1 and orange equal 0. So for this case, for this neural network, bigger neural network, and this input for this color and this texture, give me this fruit is apple. I hope you understand this part, guys. I will give you another example, but not in threshold function. We need to make it more complicated. Let's talk about another function. Then this function is called sigmoid function. Sigmoid function, it is look like this. Let me show you. Sigmoid function. Draw. It is 1 over horrible. 1 over. I think I have mouse here. It will be easy with the mouse, yeah. 1 over 1 plus e minus z. So instead of this would be y. Instead of threshold function, which is y equal, oh, it's nice now, 0 and 1, and 0 in case of z less than 0, and in case of z greater than or equal 0, you give me 1. Okay, this is threshold function to determine between two classes, apple and orange, man and woman, buy or not buy. But this, it is another function. It's called sigmoid function, and this function is good for to determine a certain value. Okay, let me show you how to draw this in your calculator here. 1 second, right here. Okay, I will come here and say calculator. Okay. This is my calculator here. Okay, in this calculator, I can come here to graphic calculator. I obviously make my now here, and I will draw. If I'd like here to draw just x, you draw the x like this. If I'd like to draw x plus 7, you draw it like this. Okay, if I'd like to draw x squared, x power 2, you draw the x power 2 like this. If I would like to draw x power 3 minus 6, we draw it. I didn't. X again, x power 3. Sorry, this is the red one. Let me delete this too. All right, this one is x power 3. The x power 3 plus minus 2. Okay, minus 2. Okay, so it is different one. All right, but if I would like to draw the sigmoid, that's what I'd like to show you here, the sigmoid. All right, the sigmoid will be 1 over 1 plus e. I think it's e right here, somewhere here, right here. E power minus, don't say z here because he will not understand the graph, so I would say x. Okay, or there's a function right here. This the sigmoid function. There's a sigmoid function right here. This bounded between between 0 and 1. This is called sigmoid function. Let me change the color. I don't know how to change the color. Ah, okay. Yeah, I think I can show. Yeah, it's color here. All right. There's a function right here. Okay. Okay. So the function. I think always I show it to you here somewhere. Sigmoid function. Yeah, this one. This is sigmoid function. Okay. Let me use this one to calculate the output or the any input. Okay. All right. I have a problem already, so I will use this problem. I will come back to these guys. All right. Yeah, look at these guys. This example, I can use it. Oh, let's use this example. All right, let's use this example, guys. And this neural network is 2, 3, 1. 2 input and 1 output and 3 neuron in the hidden layer. Okay. But if you ask me how many layer we have, I will tell you just 2. This one layer and the second layer. This not a real layer. This input layer. Okay. How can you find out about this? Okay, how to calculate these things? All right, let me do this with you. Okay, the first thing I will uh, I will go Z1. Okay, guys, this just there's the input X1 and this X2. And look at this W11, that means going from one to one, W11 and W12, and this W1 3, this one, W13 right here. Okay, because coming from 1 to 2 to 3, but this way I call it W14, this one W14, and this W15, and this W16. Okay, and this for layer 2, W21, and W22, and W23. So I start with 1 for all layer 1, and start with 2 for all layer 2. Like I say, guys, this Z1 and this is 2, and I will name it. I will name this A1, like activation 1. I will name it. I will not name it Y. And this is 2 and A2 and Z3 and A3 and Z4. I can name it A4 or I can name it Y, but I name it Y hat because it's the output. So we can name it A4 or anything. But in case if it is output, I will name it Y hat. Why I use the hat? Because it's calculated Y, but calculated is not real one yet. I will talk about real one after that. All right. Okay. So this it is Z1. Let me calculate Z1 with you. 0 point. The input 5, 7, 2, 6. I hope you can do it yourself with your calculator times 0 point. Yes, 5, 3. I hope you understand why. Plus, okay, what else here contribute to for Z1? This one 0 point 55833 plus, no, sorry, times, and time, what is the snaps is here? It is 0 0.60, okay, 0 0.60. And in this case, I will come to my calculator. Well, sorry, my calculator, I think it's somewhere here. Yeah. Let me go to my standard calculator. All right, and 0 0.5726 times 0 0.53 plus, I don't think you will do it correctly, 0 uh, 5833 times. Oh, that's not correct. Okay, so let me check with the scientific one. Scientific one. Okay, I hope this could understand the situation. 0.5726 times 0.53 plus 0.5833 times. Yes, correct. That's correct. All right. 0.60 equal. So the number here, I will take, okay, let me take the number here, copy. All right, and here, let me do this here, equal. V. There's a number right here. And how to get A1? A1, I will not use positive and negative and threshold function. I will use sigmoid. So in case of sigmoid, I would say A1 equal, all right, 1 over 1 plus E power minus Z1, which is power minus 0.65345 Okay, you can just hold the four numbers and ignore the rest. Let me do this together here. 1 over between brackets to make the numerator, the denominator, 1 plus E. What is the E? Somewhere here. E, correct, power, the power, this power, okay, E power minus, so I will open the brackets, minus 0.65345 Let me close the brackets, equal. Give me this number. Let's take four numbers. Okay, let me take this numbers, copy. Okay, so the situation here equal this number V 0 point. Okay, so this is the A1. You should calculate the Z2 and in same way A2 and Z3 and same way A3. And then you will use A1 and A2, this A1, and A3 as an input for the second layer. So A1 times this weight plus A2 times this weight and S3 times this weight to give you Z4. And then you use activation function to calculate this Y. Okay? I know it is a long process, but let's do it by code, and at the same time you can do it by Excel sheet. I will do it Excel sheet first, and I will do it for code for next lecture, right? Okay. Okay, let's do this with the Excel sheet. Sorry. I will come here. Open a new Excel sheet for this. Okay. Okay. Let's say this x1, 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 and this x2. Okay, and this z1 and this z. But after z1, I get a1 and then z2 and then a2 and then z3 and then a3 and then z4 and then A4 or Y hat. Let me make it Y hat. Y hat. Okay, hat. All right. So let me make this clear for you. Okay. Right. All right. What is the X1? X1, guys, it is 0.5726, and X2 is 0.5833. All right, how to calculate Z? Z to calculate it equal X1 times the weight, which is 0.53 plus the Z2 times the another weight, it is 0.60. Okay, again, what's wrong here? Yeah, times 0.60. No, I don't think so. Again, 0.726 times 0.52.3, and the other one 5833. Okay, I don't think it's correct. So yes, so that's the same number we have it before. Again, yeah, this cell times the weight 0.53, and this cell x2 times this weight. Okay, all right. All right, now let's do this in activation function equal 1 over 1 plus E. E in Excel is called the exponential EXP. Yes, this one. Okay, EXP when XP, it will be minus Z or minus Z1, which is this one. Okay, and then we close the. Yes, I think we had the same result here. For Z2, I will do the same, equal this input times the weight here for Z2, this weight, 0.54 plus this input time negative 0.49. Again, let me make sure this input correct times 0.4854 correct, and 0.49 is also correct. Okay. All right. So now I will go to Z3. Z3. Before Z3, I should use this. Okay. What I need to do, copy and paste it here. If you click here, guys, you will find that's the correct formula. 1 plus exponential e power negative this Z2. So that's the correct formula. All right, Z3 equal the input again times the weight for this one, 1.13, sorry, 1.3, 1.12, 1.49, 1.49 plus the other input times minus 160 Okay, you got it correctly. Yeah, the input correct. And the weight is correct. 149 and 1.6. Correct. All right. Here, copy from here, copy. And here, V. You will find the correct formula. Yes. All right. Listen, no. Yes. Okay. For Z4 it will use A1 and A2 and A3 as output, as input, sorry, and times the weight. So here I would say equal A1 times negative 33, 0.33 plus A2 times 0.14 plus A3. I think I got this not. Okay. A3 times uh, negative 16. Enter. Let me make sure it's correct. No, I need to change this one by this one. Okay, so A1 times this weight and A2 times this weight and A3 times this weight. Okay, enter. And now the height, it will be the same function. So copy V. This is the correct one. All right. All right. This is the answer that I had. What about if I have four instant? So it will be easy now. Look at it, guys. This question actually has four instant, like you see, like okay. So all I need to do to copy this and put it there. Copy. Let me check if I can click it. Copy. I hope so. B. No. Okay. B. Copy. All right. So this is the second one. The third one. Copy. B. Copy. B. Copy. The fourth example. Copy. 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 B. And all I need to do to apply the same formula for all of them. 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 Apply the fourth formula. Same formula. Same formula. Same formula. Okay. Okay, you understand this part. The final part I would like to mention here. What is a y hat means? If I have a problem like this, look at guys, this is a problem right here. All right. Actually, this problem give me this data, and this data has output. So this input and this output, and this input and this output, and this input and this output, and this input and this output. And what about if I have this input? Can you calculate the output? Actually, we have this neural network. If we have this neural network, we need to find out if this neural network is correct or wrong. If we find the similar output or acceptable error, so I will accept this neural network. So can you calculate these errors? But let's see if I can calculate the error. How to calculate the error? The difference between the actual y here and the y I calculated, this y. But this could be sometimes positive and sometimes negative. In this case, I will make it power 2. So I will keep it positive all the time. Okay. Also, since it is positive or negative, I can make it half power 2. So I have a formula I would like to tell you here about the error. The error equal, okay, y minus y hat power 2. Okay, power 2. And I can make it this one over 2. So this will be, it is not big deal, guys, to make y power 2, but it is good because some pieces is positive and some pieces negative. So we take the half of the power 2. And this power 2 we make it because I'd like to make the error all the time positive. So if I come here and I will add the actual y that existed here. So here, copy. V. Copy V. And then I will apply the formula here of error. Let's make it error. Okay, equal here, equal brackets. Let's say have first 0.5 times bracket this y minus y hat power 2. So there's the error here. Hope it's correct. I think so. Right. Okay. And well, I'll apply all this. So the error is small. And in case of this error is very small, like you see, I will believe the neural network. So I can say this neural network is somehow accurate. How to calculate the accuracy, I will let you know next time. This is the error, guys. So in case of a new data, so like what? Like this one. So since I believe this neural network it's correct, I will add a new data here. I think I copy. Didn't do the first one correctly. V. Copy. V. Okay, so I will calculate Z1 for this, and ZA1 for this, and Z2 for this, and A2 for this, and Z3, and A3, and Z4, and A4. And then I don't have a Y, so this is the output I'd like to find. Copy this one, and get this the output I wish to have. All right. Okay, this one. So if you apply this training set and you'll find the error very small, I can calculate this. Okay, what about if I don't have this weight? How to find this weight and how to find the number of to change the number of neuron? This I will talk about this next time. I hope you guys you understand this part. I wish all of you to go to the the model page. All right, and you will find these slides. Okay, you will find the same thing here, and I think it is the answer right here. Okay, all right, and I'd like to do this yourself again. Do it one time with your hand. Okay, just in your calculator, and do it in Excel sheet. And I will teach you this next time how to do it in Python code. See you next time, guys. Okay, bye bye.